In this video, we are going to take a look at Chapter 4 of your Ag Economics textbook, and the title of this chapter is Consumer Equilibrium and Market Demand. Here are a few of the key terms that we are going to discuss. You can see we're going to start off by talking about equilibrium, and then we're going to move into demand. We're going to look at the consumer demand curve, the market demand curve, different things that affect the demand curve, and then we'll finish up with consumer surplus. So first we're going to take a look at consumer equilibrium. So if you recall from last week, we looked at the budget line and the indifference curve. Today we're going to put the indifference curve together with the budget line to find the consumer equilibrium. So on this chart over here, let's take a look at this first. We see we have three different indifference curves plotted, and we have a budget line. So similar to what we needed in the previous chapter for the budget line, we are given a price for two goods. So we're given the price for tacos and the price for hamburgers, and we are given a budget. Okay, so given this budget and these two prices, we can say that the consumer equilibrium is at the point where the budget line runs tangent to an indifference curve or meets an indifference curve. So we have multiple definitions of the consumer equilibrium over here. It is the point where the consumer maximizes their satisfaction while adhering to the budget constraint, and it's the point at which the slope of the budget line equals the slope of the indifference curve. That's happening right here, where the budget line is running tangent to one of the indifference curves, or a point on one of the indifference curves. So where those meet up, that is at the combination of 2 hamburgers and 5 tacos. This should actually say combination. So the combination point where consumer maximizes their satisfaction while adhering to the budget constraint. So consumer equilibrium is under these prices and this budget. It's where the consumer purchases 5 tacos and 2 hamburgers. As we saw in the previous slide, where the budget line meets the indifference curve, that's the point of equilibrium. This slide is just telling us that points B and D are outside of the budget line. So anything that is on this side, the right side of the budget line, costs too much money. That's higher than our budget. For example, point B here is at 4 hamburgers and greater than 6 tacos. Well, the hamburgers were $1.25, the tacos were 50 cents, and if we multiplied that out, 4 times 125 is $5, and 50 cents times 6 is $3. That's going to be $8, and our budget was only $5. So again, anything to the right exceeds budget. Anything to the left of the budget line, then, as in point C, we have enough money for that because it falls within our budget, because we're only buying a little bit less than 2 hamburgers and then 4 tacos. So the 4 tacos are 50 cents. So that's going to be $2, and then looks like about 1.75 hamburgers at 125. Well, that's going to be less than 250. I don't have a calculator right now. So we're less than 450, and we have $5 to spend, so we're not spending all of our money. And the consumer equilibrium states that we're going to maximize satisfaction while staying within our budget. We can maximize satisfaction by spending a little bit more money to max out our budget there. So anything below is less than the budget, and anything above the budget line is more than the budget. We can define consumer equilibrium with a couple other equations. Consumer equilibrium is, these equations are true when we are at consumer equilibrium. So these ratios work out to be true. So if you find the ratio of the price of hamburgers divided by the price of tacos, whatever that ratio is going to be equal to the marginal utility of hamburgers divided by the marginal utility of tacos. And then if we rearrange that equation, we can rearrange it to make it look like this, where the marginal utility of hamburgers divided by the price of hamburgers is equal to the marginal utility of tacos divided by the price of tacos. Basically, these equations are summarized in the statements next to them. So this first equation is basically saying that consumer equilibrium occurs when the point where the rate at which the market is willing to exchange tacos for hamburgers is equal to the rate at which the consumer is willing to exchange tacos for hamburgers. In other words, the marginal rate of substitution is equal to the budget line. A lot of this, there's going to be a couple questions on the quiz that relate to these equations. You don't need to necessarily conceptually be able to understand them and explain them, but just be able to recognize these equations. So the consumer equilibrium can actually change. So in that previous example, we had a particular quantity of hamburgers and a particular quantity of tacos that we found at the point where the indifference curve met the budget line. This point can change, and it can change as a result of the change in price of either of the products, so of hamburgers or tacos, and it can also change in a result of a change in the income of the consumer, which would be a shift in the budget line. Maybe the budget line shifts up, maybe the budget line shifts down. So let's take a look at how some of these things can happen. So to begin, this is another snapshot of the budget line that we were working with a couple slides ago. So this is the original equilibrium point where we have 2 hamburgers, 5 tacos. Now we are going to change the price of hamburgers in the next slide, and let's see what that does to our budget line. So in this slide, we've increased the price, we've decreased the price of hamburgers. So they've become cheaper, they've become $1. Now our two extreme points, or one extreme point has changed. We can now, because hamburgers are only $1, if we spent all of our money on those hamburgers, $5 divided by $1 is 5, so our extreme point is at 5. So our budget line changed. Our budget line moved from the left to the right, which means now that our budget line is falling tangent at a different point than it was originally tangent at. So it was originally tangent at A when hamburgers were $1.25, but now that hamburgers are $1, it's tangent here at point B. So then we got to follow that tangent line down and see, okay, what is our new consumer equilibrium? Our new consumer equilibrium is at the point where the consumer is purchasing 3 hamburgers instead of 2, but our tacos happened. Nope, our tacos decreased. So our tacos went from 5 to 4. So that's our new equilibrium as a result of the budget change. In this third example, our price continues to change, but this time our hamburger price increased to $5. So if there's one hamburger for $5 and we only have $5, we can only buy one hamburger. With that, so our budget line shifted to the left, which means that our new equilibrium is now tangent to a different indifference curve, because if you recall, there's multiple indifference curves, and the further to the right the indifference curves, the more desirable it is. However, none of these points fall within our budget anymore. So we are falling on this line of where C is on the indifference curve, and we can see that the consumer equilibrium is now about a half of hamburger, and I would say 5.2 tacos maybe, approximately. So that is now our consumer equilibrium. So you can see that the equilibrium shifts according to changes in prices of the products that we are looking at. Okay, so if we were to, we have all three of the budget lines on here for each of the different varying prices of hamburgers. What these points show us are the beginning of a demand curve. Consumer demand schedule, consumer demand curve, similar things. We can take these points and change them into a demand curve for hamburgers. So a demand curve has quantity of one item on the x-axis, and it has price of that same item on the y-axis. So we can see here, if we took these exact points, this first point here is C. If the price is $5, because recall that C, the price was $5, then we demand only one burger. If the price is $1.25, so that's going to be down here, then we demand, what does that one fall? That one was at 2. And if the price is $1, then we demand 3. So we start to see our demand curve here. Okay. And they did the same thing. It was $5, demanded a half a burger, $1.25 to $1.03. So they just did exactly what we did. They had one more data point, $6 they added, they were going to demand 0. So we can take that information from the various equilibriums at various price points of particular goods to create a demand curve. The plots, as the price of the good changes, the plots change, or the points change on the plot, and we can see that here. So that's where we get the demand curve from. Now, what we just saw was a consumer demand of an individual person. So there's a difference between consumer demand and market demand. Consumer demand is if we are looking at the desires at various prices of a particular product for one person. In this case, we have what Paula is interested in buying. And then this second curve, we have what Beth is interested in buying. And then C, we have what Beth and Paula together are interested in buying. So we can see that if the price of hamburgers are $1.50, because we have price of hamburgers across here, Paula is willing to buy 2 hamburgers at that price. And if the price is $1.50, Beth is willing to buy 1 hamburger at that price. That means if Beth and Paula were the only 2 people in the entire market of buying hamburgers, the market would be at 3 hamburgers for that $1.50 price. 2 plus 1 equals 3. So obviously there's more than 2 people in the market for purchasing hamburgers, but that just sort of simplifies how we add up everybody's demands to figure out what the market demand is. So the market demand is a bigger picture of all consumers' needs. So here is a question that you're going to find in your textbook, and this is one of the homework problems. So we're going to actually do it together here on this video. So Betty and Wilma wish to buy t-shirts and shoes. Betty has a budget of $600 while Wilma has a budget of $1,200. Using the indifference curve analysis below, so we're going to look at these indifference curves. Determine prices for the t-shirts and shoes. For which commodity can you derive a demand curve? And then derive the curve for Betty and Wilma. Finally, derive a market demand curve. Okay, well, first of all, for a demand curve, we need price and quantity. That's what we're looking for. And we need multiple points. That means we need multiple prices and multiple quantities. So let's see what we have for information on t-shirts and shoes. Okay, so first we need to figure out how much the shoes cost at certain with certain budget lines and how much the t-shirts cost. So let's start here with Betty. So we know Betty has a budget of $600. At these extreme points, let's start with the 20 shoes and the 40 t-shirts. So at this extreme point, if Betty were to spend all of her money on shoes, all of her $600 on shoes, she'd be able to buy 20 of them. I know that because the extreme point on shoes is 20. 600 divided by 20 is 30. So what that tells me is down here with Betty, if the price of shoes is $30, Betty would buy 20 pairs. That's the information that we just pulled from that. Okay, because again, her budget is $600. Now, if the price of, so now we got to find the price of t-shirts. So we know that she has $600 to spend. If she spent all of that $600 on t-shirts, she would be able to buy 40 t-shirts. So let's calculate this out and see what we get here. 15 is 200, good. Okay, so on this budget line, we've got 2 budget lines. On this budget line, the t-shirts are costing $15, the shoes are costing $30. So if the price of the t-shirts are $15, then she would buy 40 of them because we have quantity over here. So these are both quantity. Okay. Now, if the price, we have a second budget line. So we figured out the everything for that red budget line there. Now let's look at this yellow budget line. So she's going to buy 20 shirts if the price is, let's figure out what that price would be. She has, again, $600, so the extreme point, 600 divided by 20, that's going to be $30. So if she's buying 20 shirts, then the price of those shirts is $30, and the shoes didn't change. Okay, that extreme point stayed the same. She's still buying 20 shoes at $30 a piece. Again, the extreme point didn't change, so the price didn't change. Okay, now if we go to Wilma, Wilma has $1,200 to spend. Okay, so we know at one point, let's do this one a little bit differently. We know her quantities. Let's put those in first. So we know that at one point she has 80 shirts, and at a different point she has 40 shirts, and then we see that both of her shoes are 40 because that's not changing either. So if we're trying to figure out how many pairs of shoes, oops, I put that in the wrong spot, I'm sorry. Pairs of shoes should be 40 and 40. Okay, so if we're trying to figure out the price of the shirt when she buys 80, we're going to take 1,200 divided by 80 to figure out the price at that extreme point. And we are going to get $15, and the price of the shirt when she buys 40, we're going to do 1,200 divided by 40, get 30 for that. Okay, and then we can double check this, but the shoes are probably going to be the same price as they were for Betty, but she has $1,200 to spend, and if we divide the extreme point by 40, she bought 40 shoes for $1,200, that's $30 a shoe. So that was the same as Betty. Okay, so we've got all this information. I'm going to erase this and clean it up a little bit. So that's great. The next question, for which commodity can you derive a demand curve? Well, in order to derive a demand curve, you need multiple prices and multiple quantities. For the shoes per person, okay, because we got to make the individual demand curves, and then we're going to make the market curve eventually. For the shoes, we have one quantity value and one price value for Betty, and we have one quantity value, 40, and one price value, 30, for Wilma. So we do not have multiple price values or multiple quantities. So we cannot derive a demand curve for shoes because we don't have data on multiple prices. But what we can do is derive a demand curve for the t-shirts. So I'm going to write over here, we need the price on the left, the quantity. I'm going to put t-shirts, quantity, t-shirts, quantity, t-shirts, price, price. Okay, so for Betty, and it looks like we have 15 and 30, 15 and 30, 15 and 30, because those are the only prices that we're working with here. So for Betty, at a price of $15, she's willing to buy 40 shirts. So we're going to do 20, 40, 60, 80. So at a price of $15, she's willing to buy 10, this is 20, 40, 60, 80, 40 shirts. At a price of $30, she's willing to buy 20 shirts. So that is Betty's demand curve. And we can see it's as the price decreases, she wants more shirts and vice versa. Okay, for Wilma's curve over here, we have 20, 40, 60, 80. At $15, she's willing to buy 80 shirts, and at $30, she's willing to buy 40 shirts. So that is Wilma's demand curve. If we are doing their total curve, the market total, down here, we have 20, 40, 60, 80. So at $15, we have Betty's 40, and Wilma's 80. That means 40 plus 80 is 120. So we got to make our demand curve higher. 80, 100, 120. So at $15, we need 120 shirts. And at $30, I'm going to try to do this so you can see it. So this was our two 30s over here. We have the 20 plus the 40 is 60. So there are 60 shirts in demand at 30. And there's our demand curve for the market. So what we did is we took Betty's demand, added it to Wilma's demand, and we got the market demand. So a lot of work for that problem, but there it is. Okay, so we had a couple examples of the demand curve. Demand curve again is price and quantity. The demand curve can change, so it can shift to the right or it can shift to the left as a result of several things. So it can shift to the right or shift to the left if the income changes, if the price of other goods change, or if tastes and preferences change. We're going to leave this one out for now because that actually causes a different change. Okay, so we talked about these things also affecting the equilibrium. So similar things that can change the equilibrium can also change the demand curve. So to start, we're going to look at income changing. So how exactly the income affects the demand curve depends on whether the good that we are discussing is a normal good or an inferior good. So if it is a normal good, let's define that quick. A normal good, consumption of a normal good increases with an income increasing. So for example, something that if you made more money, you would buy more of, me, that would be maybe Starbucks coffee. So if I made more money, I would buy more Starbucks coffee. So that to me would be a normal good. And a decrease in income will cause a decrease in demand. So the less money I make, the less Starbucks I'm going to buy. An inferior good is the opposite of that. With an increase in income, people tend to buy less of an inferior good. A good example of this is ramen noodles. Generally, people buy more ramen noodles when they have less money, and they buy less ramen noodles when they have more money. So we can determine if a good is a normal good or an inferior good by tracking its demand across various budget lines. So what we have here are 3 different budget lines. With 3 different equilibriums, point A, point B, and point C. So let's figure out how consumer demand of hamburgers and tacos is changed with increasing and decreasing budget line. And also remember, if a budget line increases, that also means the income has increased. So sometimes I'll use the words budget and income synonymously. So let's look at income or equilibrium point A. So at equilibrium point A, the demand is 2 hamburgers and 5 tacos. And the income at line A is $5. At equilibrium B, just to be able to see that a little bit better, 3 hamburgers and 5.5 tacos. And the income at that level is $6. And then finally at C, the demand is 5 burgers and 4 tacos, and the income there is $8. So if, again, a normal good means that as income, an increase in income results in an increase in demand. So our income is increasing here. We're going from $5 to $6 to $8. Are hamburgers a normal good? Did the demand go up? Well, we went, as our income went from 5 to 6 to 8, we went from demand to 2 to 3 and then to 5. So as our income rises, our demand for hamburgers are rising, so it is a normal good because demand is rising with income. Are tacos a normal or inferior good? Well, we begin to go up. First we go up 5 to 5.5, so it did go up a little bit, but then we go back, or then we go down to 4. So I would take 2 answers on this. I would say inferior because demand ultimately decreases as income increases. Or you could say that from points A to B, it's a normal good because demand increases from 5 to 5.5, and then from B to C, it's a inferior good because demand drops from 5.5 to 4. So I'd take either one of those answers. Now, we can answer the question that's being asked here with the information in this chart, but sometimes economists take it a step further and they put this information on a graph called an Engel curve. I just erased all that information now. But where they would graph the quantity with the income, and if you see the quantity increasing as the income increases, that's going to be a normal good. But if you see the quantity, like this, for example, the tacos, the quantity was going to increase for a little bit, then it was going to decrease. So that's what that graph would look like, quantity and income. And then sometimes you would see the quantity decrease as the income decreases. Oops, I'm sorry, I said that wrong. The quantity increases as the income decreases. So that would be an inferior good. This is the exact curves that I was drawing, the Engel curves. So if you wanted to put your data into this chart for the quantity of burgers and tacos, you would see that it directly translates to that Engel curve, which just more easily allows us to see if the good is a normal or an inferior good. As was stated, a change in income can cause a change in demand, and what determines whether that change will cause the demand curve to shift to the right or cause the demand curve to shift to the left has to do with whether that good is a normal good or an inferior good. So if I assume that Starbucks coffee is a normal good, what will happen to the demand curve if income is increased? I'll give you a minute to think about that. What's basically going to happen is that the demand curve will shift to the right. Why this is because at a given price, let's say Starbucks cost me $5 and my income increases. Let's say at $5 per cup, I was maybe willing to buy 2 cups per month. I'm going to say this is quantity per month, 2 cups per month. But if my income increases and nothing else changes, the price of the coffee is still $5, I am now willing to buy, my demand curve shifts over, I follow this demand curve now, and I am now willing to buy 4 cups per month. So if something is a normal good, a increase in income will shift the demand curve to the right. Other things can change the demand curve. One, we're going to look at how the price of other goods change the demand curve. Other goods can be substitute goods or complement goods. So a substitute good is just what it sounds like. It's a good that is consumed or purchased instead of the good at hand that we're talking about. So if we're trying to look at demand curves for Pepsi, Coke is an example of a substitute good. Something that generally people would choose one or the other, but not both. A complement good is something that people generally purchase together. So the example that I have here is chips and salsa. So generally you would not buy salsa without chips, and that's why we would say that salsa is a complement good to chips. And then sometimes there are independent goods. We're not going to look too much at those because they do not influence or change the demand curve or shift the demand curve because they're unrelated. So the two that we're going to look at are substitute and complement goods. So how do these substitute goods influence the demand curve? Well, let's use Coke and Pepsi example here. So if this is the demand curve over here for Pepsi, and let's say Pepsi is $5 per pack, and Coke just raised their prices to $10 per pack. Because the substitute good increased their price, people who were buying Coke might now buy more Pepsi. So the market demand for Pepsi shifts to the right. When the demand shifts to the right, a higher quantity, so we got quantities increasing across the bottom, is desired at the same price than was desired previously before Coke raised their prices. So we jumped from a quantity of A to C. The price of Pepsi stayed exactly the same, but the price of Coke increased, causing a shift in the demand curve. The opposite would happen if the price of Coke decreased. So now let's say all of a sudden the price of Coke decreased to $2. Now we would have a shift to the left, and less people would be interested in buying that $5 Pepsi because they can buy Coke for $2. Okay, so, and that's what's going on in this picture down here. A complement good works in the opposite way. If the price of the complement good goes up, people will buy less of the good at hand. So for example, if we're talking about chips and salsa, the price of chips goes up, people will buy less salsa at the given price of salsa. So the curve will shift to the left. Vice versa, if the complement good price decreases, so if price of chips decrease, everybody might go out and buy chips, or might go out and buy salsa because chips are so cheap. So let's get salsa with all these chips. So in that case, the demand curve will shift to the right. The important point to remember here is that the price of the good at hand is not changing. And when I say good at hand, the good that we're talking about. So in both of these examples, we're talking about the salsa. But the price of the good at hand is not changing. We're going to A to C, and the price is remaining the same. The price of the complement and supplement goods are changing, and that's what's causing these changes in demand. Okay, a third reason that we can have a change in demand is that consumer preferences and price and tastes change. So consumer tastes and preferences change. Some examples of consumer preferences or factors that influence consumer preferences are the composition of the population, attitudes towards nutrition and health, attitude towards food safety, advertising, and lifestyles. So these are all non-economic things, so they have nothing to do with prices going up and down. They have to do something with culture, attitude, or lifestyle. A few examples. If there's a change in the composition of the population, so in recent history in the US, our racial and ethnic composition has changed. Specifically, for example, we have an increased number of Hispanic and Asian Americans in our population. Therefore, demand for Mexican food, Asian food has increased. So that has caused a shift in the demand to the right. Price of that food has not changed, causing a change in demand. It's this outside factor. Okay, similar to that change, there's these other outside changes. So, and in regards to nutrition and health, let's say that historically information has been released linking tobacco to cancer. So that health report, that science, that research has caused for a change in demand for tobacco. So now there is a shift to the left. Demand has decreased for tobacco because of this outside research finding. Similarly, there has been in 2018, there was an outbreak of E. coli in romaine lettuce that also caused a shift to the left. Again, these are all outside factors that cause these change in demands. So just to review really quickly, a shift in the right means that people are willing to buy more of a product at a given price. The price stays the same as a result of some outside factor, whether it's a change in income, whether it's a change in taste and preferences, or whether it's a change in a complement or supplement price. Shift to the left means that consumers are willing to pay less or to buy less of a particular good at a given price than they originally were willing to, again, for the same reasons that we discussed that could cause shifts to the right. Okay, finally, a demand curve can change. So all of the ones that we've talked about thus far have been outside factors that have nothing to do with the good at hand. This last example, we're going to talk about what happens if the price of the good at hand changes. What we have when the price of the good at hand changes is we have a change in quantity demanded. And the textbook really distinguishes and has multiple test questions on the difference between the change in quantity demanded versus a change in demand. All of the examples that we previously did that shift the demand curve to the right or to the left are all change in demands. So the price is remaining constant, but due to some outside factor, people are willing to buy more at the same price or willing to buy less at the same price. A change in quantity demanded is simply a result of a price change of the good at hand. So I'm underlining that in green. Anytime there is, I'll highlight it actually. Simply a movement along the demand curve up or down due to a price change. So if steaks go from $6 a pound to $2 a pound, the quantity demanded for steaks is going to increase as long as it's a normal good. And that's just movement along a demand curve that is not a shift. Okay, so there's a big difference there. Change in quantity demanded versus change in demand. Okay, and what I was just giving an example of with the steaks before, we have this term we use called law of demand, and it applies to anything that is a normal good, and it just states that as the price of a good increases, so here the price is increasing, the demand will decrease, and vice versa. As the price of a good decreases, the demand will increase. Okay, our final slide here, the concept of consumer surplus. So sometimes people pay less for goods than they are actually willing to pay. And the difference between what a consumer is willing to pay and what they actually pay is the consumer surplus. So businesses want to minimize that consumer surplus because they obviously want to charge customers as much as they possibly want to pay. And consumers obviously are really happy when they get things for less than they were willing to pay. So if I was willing to pay $70 for a new pair of tennis shoes, then I found them on sale for $40, I'm actually really happy. And my consumer surplus there was $30 that I didn't spend. The difference between 70 and 40, I didn't spend $30 that I was willing to spend. So on a demand curve, you can identify and calculate consumer surplus pretty easily. So we're going to actually do this problem. This is another problem in your text, and we'll go through it right now. So clearly label the consumer surplus associated with a market price of $6 using letters on the graph from the previous page. Don't worry about the from the previous page, using letters on the graph. Okay, so they're saying we pay $6 for this good. If we pay $6, this is our budget line. Recall, we paid $6, so we purchased 3 of this item. So what we paid is the area of this rectangle, right? We bought 3 of them for $6 a piece. So what we paid was $18. What we were willing to pay, well, at $8, we were willing to pay 0, or we were willing to buy 0. But we would have bought, if we divide this into 3 sections here, we would have bought 1 for about, that looks like it's about maybe $7.50. We would have bought a second one for about $7. And our third one is where we were only willing to spend $6, but we actually got 3 of them for $6. So when you're calculating the surplus, there's all these little marks in here too. We would have been bought a half of one for $7.75, etc. The point is, the consumer surplus is this area of this triangle that falls below the demand curve and above the market price. So our market price is $6. I'm sorry, this was the demand curve, not the budget. So, and below the demand curve is this purple triangle right here. So how do we find the area of that? Well, I gotta probably erase some of this. But the area of that, well, we know the area of a triangle equals base times height divided by 2. Our base is 3. Our height is 6 to 8. So 2 divided by 2. So we have 6 divided by 2 is 3. So in this case, our consumer surplus is $3. Okay, I went ahead of myself though. Clearly label the consumer surplus associated with the market price at $6. So A is A, B, D. So it's triangle ABD. B is asking us to suppose the market price decreases to $4. Are consumers better off or worse off because of the decrease in market price? Well, at $4, our consumer surplus just increased. And a high consumer surplus means that you spent even less money than you were willing to spend. So consumers are better off when consumer surplus is high. So this would be better. And it says, using the letters, label the change in consumer surplus. Well, we basically went from this small triangle to this large triangle. The change is this addition of the green quadrilateral there. So if we are labeling the change is going to be points B, D, C, E. And you can just write that, and that's fine. Calculate the dollar amount of the consumer surplus in A. We already did that over here. That was 3. Be careful of your units of measurement. There might be a D on the other side of this page. Maybe there is, maybe there isn't. I don't recall. But if they ask you to calculate the change, you're just going to have to find this area here. So first you'd find the square, which 4 to 6 is 2. So you have 2 times 0 to 3 is 3. So this is $6. And then we have 3 to 6. So the base is 3 there. Times 2 is 6. This is another 3. So this additional surplus is $9. Okay, so that was chapter 4. Quick review, we talked about the equilibrium point, we talked about consumer demand, market demand, normal goods, inferior goods, complement goods, substitute goods, the law of demand, and consumer surplus. So if you have any questions, as always, please feel free to contact me, and good luck with the problems and the quizzes this week. Thank you.